Welcome back to GRE Bombs, guys. Here we have another, in this case, Bomb 10. We have a question that they ask us to find the value of n such that this equation is true. Alright, the equation is 5 to the 11th power times 125 to the 3rd power equals 25 to the 4th power times 5 to the nth power. And the options are 10, 9, 12, 11, and 5. Clearly, this is a question that is looking to see if we have some solid control over multiplication of numbers with exponents and on simplification and how to deal with arithmetic when it comes to exponentiation. Now, also, the GRE also doesn't want you to actually start plugging in these numbers into the calculator that they offer you on the online portal when you're actually taking the test. They don't want you to start chugging in 5 times 5 11 times because their calculators do not have the ability to calculate directly an exponent. And obviously doing it that way will take a lot of time. They want you to actually be able to use the rules of exponentiation, arithmetic of exponentiation. Alright, so the way that we're going to tackle this is, first of all, let me put in some of the rules of exponentiation that we're going to use in this question. So the first rule that we're going to use, for example, let's say I have the number 2. Well, not the number 2. Let's say we have the number, let's see, 16. And we have it raised to the 2nd power. Alright, so I can simplify the inside of the parentheses to, for example, 4 to the 2nd power. See, because 4 to the 2nd power is 16. And I haven't changed the question. I literally changed that 16 to 4 to the 2nd power. The first rule of exponentiation, I think is the predominant one here, is that we can simplify this by actually multiplying these two exponents. The one that is inside with that 4 and the one that is outside of everything. And I can actually write this as 4. 2 times 2 is 4, and now the exponent becomes 4. That's one of the rules we're going to use in this question. The other rule is how to deal with cases where, for example, I have 4 to the 3rd power times 4 to the 2nd power. In this case, we have two numbers raised to a power where the number, in this case the base, we call this the base, the number in the bottom, is 4, and it is the same for both. In the case when we have that, we can actually just rewrite the base, which is the same for both, and add the exponents. So I'm going to add 3 plus 2 on the top. And obviously 3 plus 2 is 5. So this becomes 4 to the 5th power. Alright, so these are the two predominant rules we're going to use. Square it right here. And now let's get our hands dirty with a question given. We start off with 5 to the 11th power. And I notice, and this is something that I guess it's more about practicing your exponentiation tables with, simple digits like 1 through 10. We know that 125 is 5 to the 3rd power. So I rewrite 125 to the 3rd power as 5 to the 3rd power, which represents the 125, and everything to the 3rd power. I'm going to do a similar simplification on the right side. 25 is more of a common knowledge that is 5 squared. I rewrite 25 as 5 squared, everything to the 4th power. And we have 5 to the nth power. Alright, we're going to use, for example, now this rule right here, the first one, where we actually multiply the exponents here. We're going to get 5 to the 11th power times 5. If we multiply the 3 and the 3, it becomes a 9, so we have 5 to the 9th power. Equals, here again we multiply the exponents. We have 5 to the 8th power, 2 times 4 is 8, times 5 to the nth power. Alright, and now we use the second rule. Since these two are multiplying and they have the same base, in this case 5, we can actually add the exponents together. So it's going to be 5, and it's going to be 11 plus 9, which is 20, so it's going to be 5 to the 20th power. Equals, in this case, again, 5 is the common base. We can add the exponents together. We're going to get 5, 8 plus n. Alright, so look, what is the question asking you now? So when will these two numbers on both sides be equal to each other? Well, 5 is a common base, is already the same. So the only thing that I need is the exponents to be the same. If the exponents are the same, then both numbers on both sides are going to be the same. And therefore, I want to find when does 20 equal 8 plus n. I subtract 8 on both sides and I get n equals 12. I look at my answer choices and I see that 12 is option C, and I circle that. So C is my answer. Option C is my answer, n equals 12. Again, a recap. I always like going over these recaps. The techniques that we use to solve these questions are these two. The first one is when you have a certain base raised to some power and everything again raised to another power. We can actually simplify by multiplying the corresponding exponents together and keeping the same base of 4. The other rule is in the case where we're multiplying two numbers that have a common base, we can actually add the exponents together and simplify that way. Alright, that takes care of this question. Another quick one. Also, remember to subscribe and like this video. I'm going to be bringing some more questions, and also type in your comments. Maybe there's some questions that you're having more of a difficulty in the GRE that you can start posting more about. I know that in my case, the questions that I'm going to start posting that I had an issue with when I was studying for the GRE are the ones that deal with graphs, because some graphs can be a little bit tricky to interpret. Alright, so I'll see you guys on the next bomb. That would be bomb 11. Take it easy.